So all that's left for us to do is to do the first derivative test on the other critical point, which is x equals pi. So we look at when x is less than pi and when x is greater than pi. So our g prime is still and ever will be sine x over cosine squared x. All right, and I need to know if this is positive or negative when x is less than pi. So once again, cosine squared is always positive, but what about sine at x equals pi? So you can either look at the unit circle or at the graph of pi. I guess let's try looking at the graph of sine of x, right? Graph of sine of x looks like this, and this is pi right here at the x-intercept, that's pi. So if x is slightly less than pi, then sine of x is positive. And then, so then we know that in that case, g prime of x is a positive divided by positive, so it's positive, so it's greater than 0. All right, and what about when x is greater than pi? So g prime of x then is sine of x over cosine squared x, and cosine squared x is always positive because it's squared. Sine of x, if we look at the graph again, if we're slightly to the right of pi, then we're going to have a negative value. So this x greater than pi that we write, it doesn't really, like it's sort of a notational convenience, because if I were over here at 2 pi plus 1, let's say, then sine of x would become positive again. But when we say x is greater than pi, we mean x is a little bit greater than pi, because what this is shorthand for is what's happening exactly at x equals pi as we go from x less than pi to x greater than pi. So that's why we also can't just use test values. We need to analyze the function to see what the sign is going to be. So in this case, g prime of x is a negative divided by positive, so it's less than 0. So we're going to say g of x has a positive to negative, so it has a max at x equals pi, because g prime of x changes from positive to negative there. All right, now we could have included the y values right away, but I didn't. So in order to fully answer the question that says find the extreme values and where they occur, I should really just state that this function has a min at 0, and then we need to know what the y coordinate is that goes with that. So our function was secant x, so we have f of x equals secant x. So cosine of 0 is 1, so secant of x is 1, so we have a min at 0, 1, and we have a max at pi. All right, and so I put in pi, I'm going to have cosine of pi as -1, 1 over -1 is -1. -1, there you go. Now, something seems strangely counterintuitive here, because I have that the min is 0, 1, and the max is pi -1. So if you sort of think about that graphically, I have a min at 0, 1, okay, that's a min, but I have a max at pi -1. Pi negative, this is down here. So the question becomes, how do these things connect up if the max is lower than the min, right? I have a max that's down here, and I have a min that's up here. Well, the answer to that is revealed by looking at the graph of our function secant x. So we can do that. We'll look at it on the Desmati. Desmoster. Come on, Desmos. Warm up them gerbils. Let's go. There we go. Okay, so functions, secant x. Assuming you guys might already know what secant x looks like. It looks like that, right? So here's our min that we were talking about, and here's our max that we're talking about. So neither of those mins are absolute, even on the interval that we're talking about. So remember that we found all of the max and mins, but only on the interval from -pi/2 to 3 pi/2. So we're looking from -pi/2 is, let's see, here's pi-ish, pi/2 is like there-ish, to 3 pi/2, which is going to be sort of over here-ish. Right, so that's the interval that we're looking at, and we only found one min and one max, and that's what they are. So there you go. That's a challenging problem. So hopefully in the next video, I'll look at a somewhat easier problem, because sometimes it's easy to get really tied up in these complex ones, and it's hard to see the forest for the trees. But here's also a summary of what we're doing. All right, so what are we doing here? We're finding extreme values of functions. In order to find the extreme values of the function, I find all the critical points. How do I find the critical points? I do f prime. I set it equal to 0. I also look for where the denominator could be 0, because that's f prime undefined. So I usually break that up into 2. Look at the numerator equals 0, denominator equals 0. All right. I test each critical point using the first derivative test. So I do, x is less than c and x is greater than c, c being the critical point, and I see what happens to f prime. Does it change sign? If it does change sign, which direction? And then you have to look at endpoints of the interval. On the last problem, we didn't have an interval, so we didn't have endpoints to check. But we looked at least one example where where you have a closed interval. You need to look at what f of a is and what f of b is, because if f of a is larger than all the other values, then that's a max. If it's smaller than all the other values, then it's a min. Same with f of b. And then remember that you might have one or other or both of the endpoints excluded, in which case you will not check the endpoints. So you're only going to check the endpoints where the interval is closed. All right, so that's sort of the basic process. We'll look at some more examples next.